So this video talks about buffers. If you need an introduction to basic pH, the pH scale, some refresher on what that's actually measuring, I would suggest going back to the basic pH video that I did previously. This video is going to build on that and start to talk about buffers. So what I want to do is give you a definition of a buffer, what it is, what it does, and then we'll talk about an example of a buffer that actually works within the body. So here is my little simplified definition of what buffers are, what they do. Basically, they're chemicals, and they are going to bind to free hydrogen when its levels are high, and they are going to release free hydrogen when the levels of free hydrogen are low. And by doing that, by binding hydrogen when it's high, by releasing it when it's low, they are able to keep the pH of a solution stable and consistent. So I talk about, in my earlier video, the basic pH video, the fact that human blood has a pH of 7.4, and that's just an average. What it actually is a range, so the pH ranges from 7.35 to 7.45, and that's something that needs to stay consistent in the body. It is very tightly regulated. Your body, if you're healthy, everything's okay, does not let you get above 7.45, because if you get much above that, it actually leads to death. So very tightly regulated. Your body also doesn't let you get much below 7.35, because if you do, it leads to death. So we have buffer systems that are active in the body, that are present in the blood, that are present in the saliva, in other body fluids, that are working to keep the pH of the body within this range. So that if, say, you eat some lemon juice or something that's really acidic and you add a whole bunch of free hydrogen into your body fluids, we don't get below 7.35 and we don't become too acidic. Or if you were, I don't know why you would do this, but to eat something like baking soda, which is a base, which is going to bind up a lot of the free hydrogen in your body fluids, a buffer is going to release hydrogen to replace that, to ensure that your pH doesn't get too high so that you can stay happy and healthy and all of those good kind of things. So one of those buffer systems that's present and working in the body, in the saliva, in the blood, is a buffer system which is known as the carbonic acid bicarbonate system. So here's where it gets its name from. This is the chemical reaction that actually describes it, and I'll talk about what's going on here in a minute. But right here we have a chemical which is known as carbonic acid, and right here we have a chemical which is known as bicarbonate. So that's where it's getting its crazy name, carbonic acid bicarbonate buffer system. So this chemical reaction and all of these chemicals are present in your blood, in your saliva, in your body fluids, so that they can buffer pH and keep it in that range where it needs to be of 7.35 to 7.45. This is an equilibrium reaction, okay? And as a reminder, what that means is the reaction can go in either direction. So we can take free hydrogen and we can react it with bicarbonate ion to produce that carbonic acid I talked about previously. And then carbonic acid is unstable, it's just an intermediate, and it always breaks down almost as quickly as it's produced into carbon dioxide and water. The other thing that can happen, because this is an equilibrium reaction, is we can take water in the blood or in the saliva, react it with carbon dioxide that's in both of those body fluids to produce this carbonic acid, which again is unstable, it's just an intermediary. And in fact, I usually tell my students, if it freaks you out to see all this stuff, you can just forget about it, because it's never around long. And when it is formed, that carbonic acid will very quickly break apart into the bicarbonate ion and the free hydrogen. So if the reaction is running this way, okay, it's binding up free hydrogen. If the reaction is running this way, it's releasing free hydrogen. So it has the potential to do either based on what's needed in the body. If you're becoming a little bit too acidic, so you're starting to head down towards a pH of 7.35, what we're going to see happening is the reaction running in this direction and binding up some of that excess free hydrogen to bring our pH back up to where it needs to be. If you're a little bit alkaline for whatever reason, what we're going to see happening is the reaction running in this direction so that we're producing and we're releasing the free hydrogen into the body to bring that pH back down to where it needs to be. So I said that I would give you an example after we kind of walked through this equation and talked about it. And so the example I want to give you is from the saliva, okay? But the exact same thing is happening in your blood. So if you could imagine this is a beaker now that's filled with your saliva. Kind of gross, okay, but it's mostly water, right? It's got some things that are dissolved in it. So I've got my little water molecule in here representing the water that's present. There's carbon dioxide that's dissolved in your blood, dissolved in your saliva as well. We've got some free hydrogen in the saliva. We've got some hydroxyl ion. Remember that body fluids are slightly alkaline, so I haven't drawn a bunch of free hydrogen in because there's relatively less than what we would see in an acid. But let's say that you like things that are sour, okay? Things that have a sour taste have that sour taste because they're actually acids. So when you think about tomato juice kind of being a little bit sour, right? It's because it's an acid. Lemons are really sour because they're an acid. So let's say you just take a bite out of a lemon. What you're doing when you take a bite out of a lemon is you are changing the makeup of your saliva and you are adding a whole bunch of free hydrogen to it. And it's dropping the pH in your mouth because you've added a lot of free hydrogen to it. Dropping the pH in your mouth is not a good thing. That your mouth pH needs to be slightly alkaline. That's what's healthiest for your teeth. And so if you bite into a lemon or something like that, you decrease your pH in the saliva because you've added a whole bunch of free hydrogen from that acid. What the body needs to do is get rid of that free hydrogen and bring that pH back up to protect your teeth and keep them healthy. So what we see happening in this case is this free hydrogen gets bound by bicarbonate ion that's also in this fluid. So that bicarbonate ion starts binding to the free hydrogen and from that producing carbon dioxide and water. So we get carbon dioxide actually being produced in the mouth. You get more saliva, more water actually being produced in the mouth as we're binding up this free hydrogen. But what happens is we bind up that free hydrogen with our bicarbonate ion and we convert it into water and carbon dioxide is we go back to our original state, right? Where we got rid of some of that free hydrogen. We took the pH that was way too low after you bite into a lemon and we brought it back up. So we buffered it. Here's another example. So going back to saliva, like steady state, what's normal in your mouth, right? It's a solution, it's mostly water. Got some free hydrogen a little bit. It's got more hydroxyl ion because it's alkaline or basic. But let's say you were to put a big spoonful of baking soda in your mouth for some reason, okay? Baking soda is alkaline and it actually binds up the free hydrogen. And so when you put this baking soda in your mouth, the baking soda would start to bind up free hydrogen and you would end up in a situation now where there's not the normal level of free hydrogen. Those hydrogen ions are gone, they've been bound up in the baking soda, and now the pH once again is somewhere where it shouldn't be. It's become too alkaline. We need to get that pH back down, right? If it's in the saliva, because that's important for protecting the teeth. If this were happening in the blood, because so many chemical reactions happen in the blood that need to occur at that pH of 7.35 to 7.45, or they just stop. And when they just stop, you die. So what happens in that particular case is we take some of this water and we take some of this carbon dioxide that's in the saliva and we react them together. And of course, as you've learned from this chemical reaction, when we take carbon dioxide and we take water and we react them together, they give us bicarbonate ion and they give us free hydrogen. So through that reaction, we start to produce free hydrogen. We start to release free hydrogen, which is going to take that pH that was too high and bring it back down to where it needs to be for the health of the body. So that in a nutshell is buffers and how they work with an example of saliva from the human body.